So 5F. A group of people have an average temperature of 98.6 degrees Fahrenheit with an SD of 0.3. So average is 98.6 and the SD is 0.3. Okay? Translate these results into degrees Celsius. And you can see the degrees Celsius equation right up above. Celsius equals 5/9 times F minus 2, Fahrenheit, or minus 32. Okay, so I need to create a new graph with a new average and a new SD. Okay, so I need to take 98.6 and plug it into that equation. 5/9 times 98.6 minus 32. So in my calculator, 5/9 times 98.6 minus 32. Isn't it nice that in the United States we use a temperature gauge that's actually a mistake? The goal was to make it from 0 to 200, kind of. But the guy who was doing it messed up. But he was 32 degrees off. And it, anyway, causes problems. So 37. What does that mean? The average in Celsius is 37 degrees. So if you want to know if it's hot outside in degrees, anything around or above 37 is considered pretty hot. You know, we kind of say 100 degrees in the United States, but 37, 38, that's about 100. If you get above 40 in Celsius, that's really hot. Okay. So someone's translate. Oh, I also need to translate the SD. So 5/9 times 0.3 minus 32. What do you think about that? That doesn't make any sense at all. Why? Okay, the SD cannot be negative. The root mean squared guarantees everything's going to be positive. So what did I do wrong? Well, let's look at the equation. What does this do to my my normal curve? Is this a slide or is it a stretch or compression? It's a compression. Okay. Does a compression change my average? Yes. Does a compression change my SD? Yes. If we double something or if we cut it in half, that changes the SD. What is going on right here? That's a shift. It's just a slide. Does a slide change my average? Yes. Does it change my SD? No. So how should we calculate the SD? Just the compression. Because the horizontal slide does not affect the SD at all. So we're just going to take 0.3 and times it by 5/9, and I get 1.16 as my SD. Does that make sense? Okay. B, someone's temperature is 1.5 SDs above average on the Fahrenheit scale. Convert this temperature to standard units for an investigator who is using the Celsius scale. So let's do the Fahrenheit scale first, just to make sure we know what we're doing. So what would a temperature be if it was 1.5 SDs above average on the Fahrenheit scale? So that's going to be over here, 1.5 SDs. How do we calculate that temperature? Well, we take 1.5 times it by the, we want it to be in degrees, right? The SD is in standard units, so I want to multiply these two numbers together. 1.5 times 0.3 gives me 0.45. What does that number tell us? 0.45 degrees above average Fahrenheit. So what do I do with that number? Add it to this, and I get 90, 0.45, so 99.1. Okay, that person has a slight fever. That's not bad at all. Okay, so can I do the same thing over here with Celsius? Well, this is 1.5 SDs. What do I do with 1.5 SDs? Multiply it by 0.16, repeating. And just to be pretty accurate, I'm going to say 1.5 times 0.1 and then a whole bunch of sixes. Okay, what does that number tell me? In what unit? In Celsius degrees. 0.25 Celsius degrees greater than average. So I'm going to add 37 and 0.25, and I get 37.5. So this is 37.25 degrees. How can I double check and make sure I did it right on both sides? How can I tell if this number and this number are actually the same? Just plug in your Fahrenheit degrees into this equation. So 5/9, not 59, 5/9 times 99.1 minus 32. And that 32.1 was actually rounded a little bit, so, or that 99.1 was a little bit off. So anyway, we nailed it. Okay.